Okay, so this time I want to implement shifts and rotates. So I've already got the shift page up here in the Intel manual, and there's a couple of things that are new in here. One is that the operand encoding has this M1 and MC, which means that it's basically RM with either just a hard-coded 1 or the CL register. And then MI is just the usual RM with immediate that we've already got. The immediates in these forms are always immediate 8, and then each size repeats the same pattern. So we've got 1 CL8, then 1 1 here, but this is for 32 and 64, 32 and 64, and then immediate 32 64. So it's repeating the same pattern. And then for each instruction, it repeats this entire block again. And the same thing will go for rotates as well, which we'll see in a minute. So if I start by just creating some tests for, this 8-bit, these 8-bit forms here, then I can just copy them for 16, 32, and 64, and then I can copy these for each of the other, instruction blocks here. Okay, so we'll create a new, we'll go to CodeGen test data, we'll just copy, let's just say we'll copy logical, and we'll call this shifts and rotates.asm. And we'll just start by doing these shift ones first. So we'll just go in the order that they are in the table. So we'll start with SAL, so shift arithmetic left. So this is R or M, and it's 8 bits. So we'll start with just a simple one like CL, or maybe we'll use DL here. So we've got DL, and then we've got a hard-coded 1. Then we've got CL, and then we've got just any other immediate, so we'll just do OX7F or something like that. Then we'll take a copy of these, and we'll do a memory address. So this, say we could do RDX, and then we'll just copy all of these for each of the sizes. So maybe we'll just actually, thinking about it, we'll just we'll get rid of those for now. We'll just do all of the register ones first, I suppose. So these ones are going to be 16, 32, and 64. So for 16 we've got DX, then we've got EDX, and then we've got RDX. Then we'll make a copy, and all of these can be RDX as a memory access. Then we basically just need to do this for each instruction. So we've got shift arithmetic left, right, and then we've got just shift left and shift right down here. So these ones will be SAR. Then we've got SHL. And then finally SHR. SAL and SHL are obviously just basically aliases of each other, but we'll keep the tests in here because it'll be nice to just make sure that both opcodes, both of the mnemonics are covered and that they both do the same thing in my encoder. Okay, so let's just use NASM again to create the listing. So we've got CodeGen, test data, shifts and rotates listing. Then we'll just take all of this over to the encoder test. So we're going to need a new group here. So this will be shifts and rotates. Okay, so let's just do, I suppose we'll just start with these ones and we'll copy it into the other ones. So this will be op SAL. We've got dx here. Oh, we need a size first, so we've got byte dx. Then this is going to be, let's just put cx in here first. Then we've got NA, then we've got NA. So these 1 immediates are just going to be I1. CX is fine here, and then these bytes are just going to be immediates as well. So these are just going to be OX7F. Okay. Right, so now I need to put the sizes in properly. So these ones are going to be word, these ones are dword, and these ones are qword. So actually I can just copy all of these, put these ones down here. These are going to be SAR. Oh no, these ones are just SAL again, so we'll copy these. These are SAL, but they're using DX as a memory access. So this will be .m. Okay, now I can copy these and replace each of the mnemonic tests. So this one will now be SAR. This is SHL. And then finally we've got SHR. Okay, so let's just run these tests. This should fail with not matching any forms. Oh, I need the mnemonics as well. So we'll go to op. I'm actually just going to break these up a little bit into groups like this. So let's put these above add. We'll do SAL, SAR, shift left and shift right, but SAL I think can just be an alias of op shift left. Okay, I think that makes sense. So now if I run it, hopefully this will be just panicking on not being able to match an instruction form. So if we go to the instruction forms in forms.go, I put it above add, so we'll just create one here. So this, we'll do SAL first. So in SAL, we've got these 8-bit one, 16 is D1, 32 is D1, D3, let's see, CL is D3. So they do follow the same opcodes, they're just, for some reason, they've just mixed them up in this particular table. So we'll do, so the 8-bit version is D0, D2, and then the C0, and they've all got an opcode extension of 4. So we'll have a couple of forms here for this. So we've got bytes. The op n for this one is going to be M1, which I need to define. Op1 here is always reg mem, and then we've got op2. I'm going to say that's I1. I'm not going to do im1 because the im digit things are like a width. So to distinguish it, I'm just going to say I1 instead as like this is an actual value, immediate one. Then the opcode here is D0, and the opcode extension is 4 for all of these ones, for all of the shift arithmetic left. And then the shift left down here is also extension 4 because it's the same as these ones here. So this one is D0. Then we've got another case here which is CL. So like I've got RA up here to test on like an operand being the accumulator register, we'll have an RC as well. And then the other one is an immediate 8, so we'll just say im8 specifically here. So this CL case is D2, and then this immediate case is C0. And I need to sort out the encodings here. So this one is, with the CL here, the operand encoding is MC. And then the immediate one is just MI, which I already have. So that's bytes. Then, let's see, we've got 16 bits, 32 bits. So let's just have a look at, we've got D1, D3, C1, D1, D3, and C1. So these are all the same. So these can just be word, D word, and Q word matches. And these are just going to follow the same patterns here, but they're just going to be different opcodes. So this is D1, this is D3, and this is C1. Then we just need some tables for the other instructions. So if we've got, I think if I do, we'll do shift right up here maybe. So we'll follow the order that they are here, and we'll skip over SAL as being an alias. So this is a SAR, then we've got SHL. So maybe here I'll also do down here, this is SHL. We'll say this is also SAL. So this one can be SAR, and SAR is D0, D2, but it's opcode extension 7. So these change to 7. Then we've got shift left, which is the same as SAL, and then shift right, which is the same thing, but opcode extension 5. So we'll take this one, we'll call this shift right. And these ones were opcode extension 5. Okay, so now I need the new operand encodings. So we've got operand encoding M1 and MC to fill in, and CX needs a new flag, RC. So we'll just add RC here, and then we need an I1 flag, which can be added to immediate. So if immediate is 1, then info or equals I1. Okay, unsupported op-n, that's fine. So on here, the M1 and MC are just going to be the same as these. So this is M1 and MC, because the RM still needs to be op1 in this case. So, okay, let's go and test this. So we've got some problems here. So we're saying got, well, let's just see, we've got DL and 1. Okay, so in the case of the M1 operand encoding, I don't need to output an immediate, so let's just go and fix that first. So we'll only do this if form op-n is not op-n M1. And then I'm getting some operand override things, and I'm also getting the incorrect opcode here. Oh, okay, I think I should be, okay, let's go to, we'll go to logical, no, not logical, it's shifts and rotates. I forgot to fill in the sizes for these, so we'll do bytes, word, D word, and Q word. Let's just take all of these. And put them on all of the memory access operands. Oh, okay, I'll have to do it one by one. So we'll go do these ones first. Then we'll go and do these ones. And then finally shift right. Okay, well that will, so those will pass. So that's shifts. If we go and look at rotates as well, where is rotate? So we've got these rotates here. So we've got rotate 9 bits, which is through the carry flag here. So this is rotate through carry. And then we've just got normal rotates without the carry as well. So these have the same operand encodings, M1, MC, MI, so that's all done. And then we can see as well that these still follow the same basic pattern of having 1 CL immediate 8. That repeats for 16 here, it repeats for 32 and 64, all the way down to here, and then it repeats for each block of mnemonics again. So I should be able to, let's just see, we've got the, okay, in these rotate cases, we don't have any aliases, I don't think. It doesn't make sense for there to be an alias anywhere yet. They're all different opcode extensions. So if we just go to the assembly, we can basically just take all of these tests here. And then just change them, change the mnemonic. So this will be RCL. Then we'll change these ones down here to RCR. These ones can be ROL, and then these ones down here can be ROR. So we'll just regenerate the listing. We'll go to operand, not operand, we'll go to encoder test. And we'll just take all of these tests for the shifts and rotates, and then just change the mnemonic. So this will be RCL, then we've got RCR, rotate left, and rotate right. So op SAL. This I'll just put these below here. So we'll just say RCL, RCR, ROL, and ROR. So these should fail with not being able to match any forms. So let's go to forms. All right, so we're just going to take a copy of all of these. Actually, we'll just take a copy of one of them. We'll just copy this one. Change it to RCL, and then we'll just make a table for each of the mnemonics that we've got. So we've got RCR, we've got ROL, and we've got ROR. So now if I test these, we should get completely the wrong bytes. But now we can just fill this in. So these are still D0, C0, D1, D3. So they're the same opcodes. It's just the opcode extension has changed. So RCR is opcode extension 2. RCL is opcode extension 2. There we go. Then RCR is opcode extension 3. ROL is extension 0. And then ROR is extension 1. Okay, so that's shifts and rotates.